Alright class, sorry again that I can't be here today. We get to go have a speech tournament, yay! So you guys will have fun without me today. You guys are going to talk about simplifying trig expressions, and you're going to prove some trig identities. Okay. So Seb, you can pause the video so students can write this down if they desire. Okay, so we're going to keep this short and sweet. Some fundamental identities that you're going to need to know. First off, we talked about the reciprocal identities. For instance, cosecant of x equals 1 over sine of x. And of course, you could have that sine of x equals 1 over cosecant of x, right? Same with secant of x equals 1 over cosine of x. Cotangent of x equals 1 over tangent of x. Tangent of x is sine of x over cosine of x. And cotangent of x equals cosine of x over sine of x. So students, please write this down. So you can pause the video so students can write all this down if they have not already. The Pythagorean identities we referenced briefly before. Sine squared of x plus cosine squared of x equals 1. Tangent squared of x plus 1 equals secant squared of x. And 1 plus cotangent squared of x equals cosecant squared of x. And then we have the even and odd identities, which are new to us. Sine of negative x equals negative sine of x. Cosine of negative x just equals cosine of x. And tangent of negative x equals negative tangent of x. So for sine and tangent, you can almost pull out the negative out front. So before you guys complain and ask, yes, you will have a cheat sheet on the test. You won't have to memorize all this, but I would have this written down because it'll make your homework a lot simpler. Okay, so again, Sub, please pause the video so students can write all this down. Okay, so here's an example. We're asked to simplify this. So we're going to use some identities that we just talked about to simplify this. Okay. Well, cosine of x, I'm just going to leave as cosine of x. Oh, it doesn't want to write. There we go. Tangent of x is just sine of x over cosine of x, right? So I can write this as sine of x over cosine of x, and then we still have that times sine of x. Okay? And so if I rewrite what we have then, we really have cosine of x plus, well, sine of x times sine of x, sine squared of x, right? And then that's over cosine of x. Well, maybe we should write cosine of x as a fraction over cosine of x, right? So we have a common denominator. So you'll have to multiply cosine of x by cosine of x. But then we want to multiply by the fancy 1, so cosine of x over cosine of x. So if I rewrite what I have cosine squared of x over cosine of x plus sine squared of x over cosine of x. So if we throw it all together then, we have cosine squared of x plus sine squared of x all over cosine of x. Oh, well then look at your first Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. So our numerator, or the top of the fraction, is just 1. So it equals 1 over cosine of x. Well, what does cosine of x equal? Sorry, 1 over cosine of x equals secant of x, right? And that would be your answer. We just did some algebra, used some identities, and we went from this monstrosity up here, and we found that that equals secant of x. Okay? So when we're doing these problems today, you just got to think how can I rewrite these to simplify the problem? And so you're gonna look and try to use your identities to do so. Okay? Well, let's do a second one. Oh, this looks fun. So let's get a common denominator here. We have sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Okay, and so this is using some ideas from Algebra 2. Well, what this denominator on the left is missing is a 1 plus sine of theta, right? So I'm going to multiply by 1 plus sine of theta. But we don't want to change the problem, so we have to multiply by a fancy 1. So the same thing on top and on bottom. Well, let's look at the right side now. The right side's missing cosine of theta. So let's multiply the top and the bottom by cosine of theta. Okay? And so I'm going to rewrite what I have here. Sine of theta plus 1, you get sine of theta. Sine of theta times sine of theta is just sine of theta squared, correct? Okay, and then on bottom, I'm going to leave this as a nice fraction, 1 plus sine of theta, and then cosine of theta. And then we have plus cosine of theta squared all over 1 plus sine of theta times cosine of theta. Okay, well, we have common denominator now, so we can add the numerators, right? So we can do sine of theta plus sine, should be theta there, sine squared of theta plus cosine of theta squared all over 1 plus sine of theta times cosine of theta. So is there any identities that you can think of to simplify this? Sub, you can pause the video and give the students a second to think. Well, if you look, we have sine squared of theta plus cosine squared of theta. Okay, right? And so we have an identity that tells us that equals 1. So I'm going to rewrite what we have. We have sine of theta plus 1 all over 1 plus sine of theta times cosine of theta. Well, look, we have a factor on top and bottom, right? We have the same factor. We have sine of theta plus 1 on top and bottom. So just because they're in different order doesn't matter, right, for addition? And so these actually cancel out. So what's left on top? We have 1, and on bottom, you have cosine of theta. So we're going to use the same identity as the last problem. 1 over cosine of theta equals secant of theta. And that would be your answer. We just simplified that ugly mess to be secant of theta. Okay? Well, let's look at a final example. I think hopefully today is easy for you guys, a lot of work time, so you can finish up your homework. So we have cosine of x all over 1 minus sine of x equals secant of x plus tangent of x. So sub, if you want to pause the video and have kids think about this for a little bit, feel free to do so. Okay, so I'm going to Okay, sorry about that. So we're going to use an idea that we discussed, or you guys discussed in geometry, and that's using conjugates. Okay, so if we look, 1 minus sine of x is very close to 1 plus sine of x, but we can't simplify that any. Okay, so if we look at cosine of x all over 1 minus sine of x, well, we can multiply by the conjugate, which is where you just change that middle sign of the denominator. So we're going to multiply by 1 plus sine of x over 1 plus sine of x. Okay? And so you get cosine of x, and then I'm going to leave this as a product, cosine of x times 1 plus sine of x. And if you multiply out 1 minus sine of x and 1 plus sine of x, you'll get 1 minus sine squared of x, right? Okay. Can we use any identities here? Well, if you think about it, let's use one of our Pythagorean identities, sine squared of x plus cosine squared of x equals 1. Well, if you wanted to solve for cosine squared of x, you subtract sine squared of x over, right? So it equals cosine squared of x, and that equals 1 minus sine squared of x. Oh, look. We have 1 minus sine of x over here, and we know that equals cosine squared of x, right? So if you don't mind, pause the video because I'm going to erase this work down below. Okay. So we know that we really have cosine of x, 1 plus sine of x, all over cosine of x. Okay. Well, this is going to turn out nicely for us. Hopefully you guys see that. Oh, sorry, this should be a cosine squared of x. Well, if you have a cosine of x and cosine squared of x, those cancel out, right? Or at least one factor of it. So this equals 1 plus sine of x over cosine of x. Okay. Well, you have 1 plus sine of x over cosine of x. So what can we do there? We can split this apart. If you recall skills from algebra and algebra 2, if we have a fraction adding, we can split this apart as 1 over cosine of x plus sine of x over cosine of x, correct? You guys agree I can do that? Okay. Well, 1 over cosine of x equals secant of x, right? And sine of x over cosine of x is tangent of x. Well, let's look back up. We were asked to prove the identity. And so we did some finagling, and we got our answer to be secant of x plus tangent of x. So, ka-ching, we proved this. Okay? So now don't freak out. You have a longer assignment, but hopefully you have plenty of work time in class. Make sure you guys behave. Make sure you finish this in class, please. Turn it in. And I hope to see you all Tuesday.